Okay, hello. It's time. Oh boy. It's time. Shoot. I have to turn off my audio on. Okay, hi. Today we're doing something a little different, insofar as that we're doing actual science. Oh, okay. I guess Rin may or may not join us later. Let me double check. Let me just get my lab partner here. Okay. I thought, like an idiot, that I had everything figured out already, but as it so happens, I'm kind of dumb. And don't worry, this part will be edited out of the YouTube post of it. Yeah, okay, so Rin should join us shortly. Today. So we're doing like a three-part thing, right? Three-part series. And I apologize that I'm looking here. The camera's there, but the screen is here. So the part one of this is we're going to discuss the eye for humans, although it kind of applies to other animals. I'll touch on that briefly, and then I'm going to, by way of example, show you how the basic I guess visual input happens before like the brain and the chemicals and everything take over, which is I'm gonna try to avoid like the brain aspects of it too much, because that's like its own thing that I'd love to discuss sometime, specifically because it's my area of study, which by the way got into grad school. Nice going me. Cognitive science. It's only a graduate certificate, but you know, we'll go for there. I know. Thank you for all the congratulations. Okay, so while we wait for Rin to join us, we are going to need some supplies for today. As you may have known from the posts, we're going to need some scissors, some tape. What do we got here? Aluminum foil. This is way too much of it, but you know, too much is better than too little, I suppose. And some paper. And whoops, haha, sneak peek. And it would help to have a bright source of light, but I was unable to get the So okay, for this to work, right? It's exemplifying light. I can't make it dark enough to where the camera can pick up the light while also like exemplifying what's happening. I can cast that light source itself as the image, but I can't cast anything that's brightly lit because of the lighting issues. I tried, and maybe in the future we will we'll be able to like touch back on this for a second. But I just this is not like the super nice raffle that I was alluding to earlier. But this monstrosity, which I will explain in a bit, is what's being raffled today for some lucky patron. Which, as long as we're talking logistics, let's talk about what's going on with this channel real quick. Hey! So starting today, we are testing out a new format for things. In the past, well, you know what? Just don't look at the past videos. They're terrifying. I guess look at the one for the screen printing. That one was pretty good, and that was sort of where the idea for moving forward came to me. That and my beautiful and wonderful wife, who told me that my stream was garbage and that I needed to fix it. So here we are. Moving forward, we are going to try and keep the part of the stream that actually has some scientific or educational merit to it, haha, I know, down to like between an hour and 2 hours, because that's a lot and then I will be posting these edited down for time, hopefully around like 30 minutes. I can edit them down to and put those on YouTube. I'll put like the full stream up there too, just in case anyone wants to see it, but the important bits will be in their own little video. And the raffles. So I have updated the Patreon because I had kind of forgotten that I made it for a while, but now that I've remembered, I've fixed it to a large extent. Each tier of Patreon subscription entitles you to a single entry of the raffle per tier. So let's say that you are tier 2. You get one for the tier 1 before you, and then you get a second one for your current tier. So you have a total of 2 entries into a raffle. The way that that works out is that essentially I put your name on 2 slips of paper and pulled them from a hat. That's not actually how I'm doing it. I'm using a little electronic method until I can get something like a little bit cooler to look at, but as it stands right now, I've got an Excel spreadsheet and I hit random on it, and then I read off the name. There are also other cool things in the Patreon. Free prints, free shipping, a free commission, things of that nature, which is cool, I should think. And yeah, you should check it out. Even if you don't end up subscribing, which you absolutely should, you can go over there and look at all the cool things. We're going to have a merch store soon, but I don't know the details of that quite yet. I know that that this bad boy is going to be up there and available for shirts and mugs and whatever fucking nonsense. Whatever, we'll figure it out. We'll figure it out later. Okay. Rin has joined us. Oh no! Oh, hang on a second. I have to. The Discord chat isn't showing up. Let's just fix that real quick. Do 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 do. Yeah, it's not showing up. Rin, that's the wrong chat. Rin. Again, I'll be editing all of this out. Don't you worry, both of my viewers. Can I send a straight up invite directly to the right thing? Let's see. That should do it. There. Yay. Hi.
Hi.
Do it.
Oh god, I didn't read this. Good god. Oh no. Oh no. Hold on. Oh god, I didn't read this. Good god. Oh no. Hold on. Oh god, I didn't read this.
Yeah, definitely editing out the whole first part of this video.
Well, I mean, you can put your intro there. You know, that was good.
I mean, I already did my intro, so I'm just gonna like cut it while actually, I gotta cut this part anyway because I'm still trying to figure out why this chat is not showing up on the screen.
Writing is horrible.
How do I do that? Is it like a webhook? I know that there's... I forget how I did this in the first place. I think it is... Ooh. I think it's just like a straight up URL.
I need to go post this everywhere.
Hop on it. We got plenty of fucking time.
Do I?
Copy ID? Is that it?
Sounds right.
Ah, yes, that's a string of numbers. Exactly what I was looking for. And it's a different string than I have right now, so surely this will work. Ah! It worked. I have a feeling I'm going to have to do that every single time I make an edit to the channel.
Hey.
Okay. So you missed it. Let's go over it again so I can edit out everything that just happened. I touched on like patron shit or whatever, but today we're going to be learning about the human eye. And in case anyone doesn't know, this is a human eye. Look at it in all of its splendor.
This. What? Wait, where are you showing this?
It's on the Twitch, because I can't like overlay on the Discord as well.
I'll open both up.
It's a picture of an eye.
Oh, perfect. I have already so many opinions.
Yeah.
Please carry on.
I'm really excited moving forward. I hope to let's get rid of that. I hope to be able to talk about brain stuff, but not today. We're keeping on task, which I've already gotten off of. So, I guess I did the thing about what we need: the tinfoil, paper, scissors, tape. Oh no, I forgot a pin. Uh-oh.
Is it not a needle?
It is.
Totally see this, right?
It is a needle, but I don't have a needle. 1 second, I gotta go get a pin.
Oh god.
So yeah, it's a needle, but I have a pin, and you know they're the same thing, so it's fine. We're not sewing. Okay.
Perfect.
So, how should I do this? I should probably like describe what it is first, and then go into how to make the thing. So let's do that.
Yes. I mean, well, did you introed your current series, right? Did you like do a vague?
Right. Yeah. I didn't specifically mention what we're doing the other 2 days, but today is vision and how we get it into the eye, and not touching on what the eye does with it. Next time, we are going to delve a little bit further away from that into optics, which will help us segue into the third section, which will be how our body processes images, videos, and things to get us into seeing motion. And that's when the raffle happens. So get on those patron subscriptions. Although I am raffling off a thing today, but it's like a garbage thing, so it doesn't really count.
On it.
I should probably do shout-outs real quick while I'm loading up this thing.
Can you like mirror the images? Because it's really triggering.
The what?
I don't know. But the images are flipped.
Oh.
Oh, you want to talk about that? Boom. It's relevant.
Well, yeah. Go for it. You handle that while I load up my notes.
I want to talk about that.
Okay. Well, so that actually is a large part of what's going on today. When light so light is always just coming straight. Photons go in a straight line. Don't worry about the like larger implications of how that's wrong. For our purposes, in the low level of physics that we are working with on a relative macro scale, light travels in a straight line. So, if you have a tiny opening, you've got photons coming at it directly. That's fine if they're coming straight on, they pass directly through. However, if you've got photons coming from this direction, they're going to come through and hit that side. So, all of these photons are doing the crissy-cross. So you're ending up with, how do I use, you know what? I have so much paper right now. Let me just draw it.
Perfect.
So you've got yourself, I have to do the teacher thing where it's like, okay guys, now I'm not an artist. So you have a little hole in a wall, and you got your photons come in because they're kind of waves. And this one gets through, and it comes through and hits this other wall. Now, this is not the double slit experiment, although it kind of plays into it. So you also have photons coming from like every other direction because we live in a society, and they're just everywhere. So the photons coming in from down here come over here, and the ones coming up from the bottom kind of go right here. And so suddenly you've got images of like the number 1, the number 2, and the number 3 coming through. Number 2 is over here, number 1 is up here, number 3 is down here. It's upside down. It's in 3 dimensions, it's also reversed, so it's a complete mirror opposite, instead of like, oh boy, have you ever thought about how like when you see something in the mirror, it's just flipped like horizontally but not vertically? You ever think about that? Isn't that weird? Anyway, yeah, so that's why it's kind of why what's going on with the camera right now, except the computer is acting as our brain and like flipping it in one direction but not the other. Although you could just turn that off, Rin, if you want to like disable that feature.
Ooh, how do I do that? Why would it do that anyways? Why would it mandatorily do that?
Because it's
we'll deal with that later.
Okay. All right, so by way of example, let me show you what I'm talking about. I happen to have a thing here. So, oh, I shouldn't have done this. I'm going to show you the thing, and then I'll explain why, and then how to do it. So, here is the thing, and I guess actually I need to have this down here. I had like so many fucking cameras, and then all of them I lent out so that people could play D&D with me. Nope, that's not gonna work. Alright, so this is my scratched up desk, and up here we have a bright light. You can even like see the precursor to what's happening there, this little ring right here. So that's the shape of the light, the little lens flare. So I'm going to do a magic thing off camera and produce a flawless image of that light, which is definitely working. There we go. That is the light. That's exactly what the light looks like. How did I do it? It's magic. And it actually...
Next time on the spinning, it's this time.
It actually is magic. No. Because photons are magic. So what I did, as I alluded to in the picture earlier, is I have a hole made with a pin in this sheet of paper. If I had used cardboard, it probably would have worked better because I'm just now realizing how transparent paper is. But anyway, I wanted to do an example with that would have been a little bit better because it would have had more shadow thing going on, which is where I'm going to take a brief detour and show you today's raffle item, this crappy box I made with a pinhole in it. I was supposed to be able to put the camera in here and it would see the image of what I was showing, but as it turns out, even though there's an image of a light in there, you can't fucking see it because I'm using a fucking webcam. And those things don't adjust for brightness very well. So, okay, how did I do it? How did I perform magic? Well, let's pop open the drawing shit tab right here. This is our eye that I alluded to earlier in glorious Microsoft Paint.
So many things wrong with that design. Carry on.
Do you want to touch on some of them?
Why our eyes are backwards?
Go on.
Our eyes are backwards.
Do you want to like cover optic chiasm and all that crap, or?
I was literally just going to talk about cephalopods, and that's it.
Oh, we'll touch on that. That sounds cool. Tell me about cephalopods.
Cephalopods have eyeballs the right way. Isn't that neat? Ours are backwards. Something, intelligent design. Okay. Now, I will draw a picture. Once upon a time, humans evolved. Oh, controversial. Oh, that's a really derpy looking eye. Okay, that's fine.
I need to figure out a way to get you to screen share your crap.
I
also need to figure out how to stop you from coming in through my mic, although that's my bad. I turn. Oh my god, you're at 200% volume, no wonder. it's probably fine.
This is the most poorly rendered image I've ever seen. Surely it'll get the point across. Probably. I'm an artist. I don't know if anybody knew that. Please check out my art. Okay. Yeah, I should label. Okay, here's my very, very good drawing. I hope everybody can see this. So, the important part is, and you can see a better drawing in the stream, is cephalopod eye has the photosensitive cells right here. Retina, the one that Trump stared at and probably burned out. The cells are in front of this. This is the optic nerve, which you can think of it as a data cable from visual information into your brain. So cephalopods have this photosensitive cells in front of cable, if you will. We, for whatever reason, have the cable in front of and kind of in the middle of, in the midst of all of our photoreceptive cells. In other words, our cable is okay. Imagine you're watching TV, but instead of the cable being plugged into the back, it's literally through the middle to where the cable is visible on the screen. That's kind of how our eyeballs work. Our brains are very clever and are able to kind of fill that gap. But if you do any experiment in which you notice your blind spot, that little actual blind spot is where optic nerve is. And that's why you can't see there.
That is the optic disc, as it so happens, which is right. Hang on, let me pull up some red. It is right here. Oh, that's the nope. That's the selection tool. Hang on, here it is. Yeah, right there. That is not red. Whatever. That's the optic disc, and yeah, as you mentioned, it is that because there's a nerve there, which is, yeah, I mean, it's dumb. Intelligent design, am I right? There's also to counteract this point of the optic disc, just above it, assuming that we're talking like in terms of like rostral, caudal, and all of that, we have this fovea. Well, red is even worse. Get a thick boy of yellow in here. This. Oh, wow, I missed this fovea.
So please translate your words.
A fovea is, actually it's a little divot, right? So you have this wall. You can kind of see it here, but I think you can see it better on here. there's this little there's a little divot. Oh, this one's not labeled. I think that's why I pulled this up on the computer instead. There's a little area right here where the wall of the eye kind of indents a little. That is because there are more cones there than there are rods. And what are rods and cones? They are specialized cells that contain opsin and rhodopsin. And I'm not going to get too much into that, but basically rods collect any light at all. They don't really care what kind. And then cones, which are kind of shaped like this but otherwise look like rods, collect very specific types of light. And each rod will only care about two, and they're linked together. So if you're seeing one color in a rod, you're not going to, or a cone, you're not going to be able to see that color like it's deactivated in the surrounding ones. Not that color, but the opposite color. So this is why if you stare at an image for so long and then close your eyes, you see the negative of that. And that's kind of cool. But these only really exist in the fovea. They're kind of like sprinkled throughout because, you know, evolution, fuck it. But in that very center disc, you see a lot of detail because of that, because it's highly sensitive. It also happens to be where, if we had our light coming in before, we have it coming in here. There happens to be a focal point right there. That is, I've messed up this picture a lot, and I probably should have used like a tablet and a pen, but you know, we're doing this instead. So that focal point, or where the light is like perfectly spaced between where it's crossing so that it hits a point of like clarity, to the distance. It's more or less equidistant, although that's not exactly true, to the distance of the thing on the outside. Now, our eye obviously is tiny compared to what we're seeing on the outside, so we don't really have the luxury of a huge amount of like moving our eye, although that would be really cool. We can't like telescope our eyeballs out. Instead, we have this neat thing called a lens, which is right here. It's exactly what it sounds like. It's a fucking lens. The way that lenses work, if you're not familiar, is they're a separate medium from what the inside and the outside medium is. So it kind of bends light, and it's curved either convexly, which is like bulbous, or concavely, which is the opposite of bulbous. It's cavernous as it caves in. That's how I remember the two. Concave, you have light coming in, and then it comes out like kind of the same. It kind of widens the beam, I guess, so if you need to focus stuff far away, that's cool. Convex is bringing light in and kind of narrowing it down. That's what we have going on in our lens, because that's the only thing we want to do is narrow that like distance that we can see clearly at. And we have these neat little things here. They're ligament. Oh, I missed. We have these ligaments right here. That was way too big, but you can see them right here. That are, I mean, you know what ligaments are, right? They're muscles connect to a thing, but the muscle doesn't connect directly to the thing because that would be deleterious to the thing. So the muscles pull on these little strings instead of connecting to them directly. And pulling on that strengthens the tension, increases the tension, whatever. It increases the tension on the lens, so it kind of flattens it out a little in case we need to like focus further away. It kind of relaxes. No, opposite. It relaxes as we focus further away, and it tightens as we focus something closer, which is why if you kind of like space out, everything in front of you becomes blurry, and you're literally staring off into the distance. And if you've ever like tried to focus on something real close, it kind of strains your eye because those ligaments are really pulling hard and your eye muscles are not very powerful. It's why so many of us have vision problems. I said wearing a pair of like fucking reading glasses.
You just say us, not y'all. So
What?
just say us, not y'all. You didn't exclude yourself from the demographic there.
Yes. Good linguistics. But okay, to use this lens, we still need to let some light in. This is the pupil's job right here. The pupil is literally just a name that we call for the hole. That's all that it is. It is the absence of material, which is not entirely true. There's not a vacuum in there or anything, but it's an opening in the iris. And the iris, if you've ever dicked around with the camera, is like kind of like the shutter. I mean, it's also called the iris, I think, or the aperture, whatever. And this adjusts for more or less light, which is part of the problem that I'm having with the example I showed you earlier. I can't adjust how much light is coming in, and thus I cannot like make it brighter than the surroundings. Whatever. Camera doesn't autofocus. So when it's dark, you need more light to see things, so you can basically have more opportunities for your cells to activate because there's more photons coming in. Oh, I should also, like, quick note, your rods and cones, I don't think they like explode per se, but they're not really usable for a while after they're being used, so they have to like refresh a little, which is one of the neat things you can do during sleeping is be able to see better afterwards. So if you're like having a hard time seeing at the end of the day, it's due to a combination of factors, not the least of which your rods and cones are like real tired, bro. Anyway, so you ever seen eyes dilate, getting really big? That's usually because it's darker, although sometimes that can be a what is it? Is it the not the what's the system with hormones and crap? Not the pituitary system, but the something else system.
Oh God.
Doesn't matter. It's been a while since I studied neurobiology. Um,
I've never.
Anyway, there are certain things like seeing something you really like that will cause your eyes to
Like
open
a
up.
cute boy.
Yes, like a cute boy. Like every time we look at your husband, our eyes get real big because they just want to take in as much light as possible. Um, it's the droogs. Are you talking about the drugs? um, yeah, the drugs will do that too. That's actually a
That is
thing.
also true.
When you go to the eye doctor, that's what they do is they drop some drugs in there, so that they can see inside better. Because then
Those
you're
really just relax the iris to where it forcibly stretches, and it doesn't really let you tighten them again, which is why you aren't supposed to drive after that, because you can't actually, your eyeballs no longer able to properly control the reaction.
yeah, and that's bad. Also, like whatever the opposite of night blindness is. Anyway, so the iris is also more, and you can see it here. It's more of this muscle tissue. It's a straight up muscle. Although, let's touch on the iris and colors real quick. Neat thing. I didn't pull a bunch of resources for citing sources and whatnot, but if I recall correctly, the eye colors more or less, I mean, recessive and dominant genes there that also are like linked with hair color and a plethora of other nonsensical things. But dark eyes do a better job of like kind of seeing in the day because they absorb more light, which means that there's less like lens flare essentially going on. Whereas if you've got like blue eyes or really light colored eyes, more of that light is going to be, you're going to increase your bloom and your God rays on your graphics card, and then all of a sudden, like, why are we even playing? I can't see the guy sniping me from like 2 feet away. I guess I need to turn down the rendering so the grass isn't visible. So that's cool. I'm not sure. I don't remember if this was supposed to be like a intentional advantage or disadvantage. I think it was just like everything in evolution, just oops, all gene traits. Moving outwards from the iris, we have this.
No, that is definitely intentional. Think about it. People like are Scandinavian, where it's colder and there's lower lights and more overcast. They have lighter eyes, and then people where it's much more summery, think of in the tropical zones, have dark eyes.
But the problem is if you go far enough north where it is really cold, you've got snow blindness becoming a problem. So you really want darker eyes.
That's true, but you don't see that a lot. So maybe as it does, evolution has a limit. I don't know.
It's beyond our power. This is beyond science. So speaking of beyond, as I was saying, just beyond heading outwards, away from the inside of our body, we've got this little goopy area called it's the aqueous body, I think, but it's water. It's water. Because when we were evolving eyes, we were underwater, and that was nice because there was water inside, there was water outside, light was traveling all through the same medium, and everything was working great. And then some asshole was like, well, what if we live on land? And then suddenly vision was a problem because there wasn't water everywhere. So what did we do?
That's why whales were like, fuck that, I'm going back.
Pretty much. They still have mammalian eyes. They can see in the air, but like, let's be honest, why would you do that? It's better down where it's water, under the sea. Although if you go deep enough, why do you even have eyes? There's nothing down there, so you become some sort of eldritch horror. Anyway, so the aqueous humor, which literally means water, and then humor from once upon a time when everything was controlled by like bile, blood, mucus, what was it, phlegm, and then the fire one.
For the 4 humors, yeah.
Which
not very funny.
Just wait until we get like miasma theory. Anyway, God, we should do that. I should do a series on like medical science throughout the ages. That would be a really good reason.
Yeah, let's drill a hole in my head.
Trepanning. Right. So anyway, aqueous humor. This time for real. It's water that you have in between your lens and the outside of the cornea, which is just like the clear lamination that you put around an eyeball so it doesn't go everywhere.
That's right, kids. Your eyes are laminated.
They are. To keep the water in, and also to like prevent infection or whatever. But that water helps because it normalizes the light into a medium that's not going to be like, if our eyes were just like, if that lens was straight up against the air, things would be real wiggly because air is not of a completely consistent temperature, whatever. Anyway, this is basically like we're massaging the light to like calm down a little bit before we put it through a lens. And then, as I mentioned, just outside of that is the Cornea Corneria, the fourth planet of the Lilat system. If you get a scratch on this, it hurts and feels like there's sand in your eye, but don't like mess with it further because you'll make it worse and you could possibly like rip it open. I knew a guy once with the runny egg eyes. It's nasty. Speaking of runny eggs, going further into the eye, we've got this cool stuff called Vitreous Humour. Vitriol, that was the other humor. I forgot it. Again, eyes were like a thing that we could take apart really easily. So we were one of the first things we were like, oh, let's dissect human beings. What's this? Ew, it's goopy. That must be the vitreous humor. You should eat more fish guts. That'll help that. The purpose of that is the same thing as the aqueous humor, except it's a little thicker and more jelly-like, so it helps hold your eyeball in shape. If you get punctured and you have to leak that, they have to inject you with some silica. No, what is it? It's a replacement thing, so you have like, like a boob job in your eyeball. And I don't know if you have to like re-up on that, but to my knowledge, the vitreous humor that you have is kind of what you're going with for the rest of your life. And it can harden, and you can get like little floaters and stuff, and that's like a diet thing. I don't remember. Like I said, I didn't really do a lot of research for this. I did. I read it all, and then I forgot it.
You read about how carrots really do help?
Explain.
I remember it's beta carotene. Beta carotene, which helps produce vitamin A, which is in general just good for your eyeballs. And I know very specifically it's for keeping the cornea good. So you'll see it a lot in malnourished like kids and stuff, but they go blind due to vitamin A deficiency. So no, carrots won't give you like super dark vision unless you're me.
Or you take that perk.
Yeah, I took that perk. But it does in general help eyeball health. And they have done experiments where if you take vitamin A like supplements, including with carrots, like it doesn't matter actually how you get the vitamin A, but carrots are good. So
I mean, yeah,
take carrots.
Biting into a carrot is like biting through a finger. Why wouldn't you?
I don't know about all that, but it does help eye health and keeps your night vision at a normal level if you have bad night vision. So low light vision, so don't get those TC debuffs.
It's such a common thing for most races, and it doesn't ever matter until it does, and then you're like, oh no, so many of us don't have it. Oops.
I just rely on other people that have flashlights.
The bad call. Even what? I guess like.
I'm the cat.
Didn't we used to call you that?
Continue.
Right. So the text is starting. The chat text is starting to override here, but that's fine. We're gonna move forward anyway. So you've got that. So the choroid is. It's usually black or very dark in humans because we want to see well, so we don't want a lot of light bouncing around. I'll get to the retina in a second, but in animals, I don't remember the name of the substance, but it's very reflective because they don't really care about acuity. They just want to see motion and like basic outlines of things. And to be able to see that in darkness, they don't have a lot of cones, first off, and secondly, they've got a reflective coat there, which is why if you're out in your backyard in the middle of the night to smoke and you see a pair of glowing orbs, you should not immediately drop your cigarette. You should instead shine your flashlight to see what sort of horrible creature is there before it eats you.
That's really rude, also, but yeah, it's fine.
We have raccoons, and like it's spooky because they'll
You
be
ever
like,
seen a raccoon? They're adorable.
I know, but when they're on the fence, they're like human height. And if you see eyeballs glowing at human height, you're like, no, thank you.
Okay, that's hilarious.
Anyway, in humans, the choroid is dark so that we can see things clearer but less good in light, which is why we don't have dark vision. Just outside of that, and this is where things get stupid in non-cephalopods, that's where our retina is. And here's the dumb thing about the retina. All of the cells, the cones and the rods that I was mentioning, they're facing towards the choroid. They're not facing outwards. They're facing this way. So not only does the light come in backwards, but essentially it has to like a projector pass over me and then like bounce off of a thing so that I can see it. And there's a reason for this, and I don't remember what it is, but it has something to do with like being able to see well moving forward. Yeah, it's really dumb. Evolution is stupid, but there are some advantages to doing it this way. First off, it filters out a lot of that. You know, even though there's a lens and a pinhole thing going on, there's still photons are still, you know, they're wild, man. You got to get that stuff in check, so you have a little bit of like.
In case anybody was wondering.
The what?
Earlier. Particles.
You're talking about how photons are actually pixels, and that the Planck constant is the universal like resolution.
Oh my god, it is.
Anyway, we live in a simulation. The universe is a hologram. So anyway, they're passing through. Actually, I think I have a picture for this. Let me see if I have my retinal layer.
Simulation theory is worthless. Do something better with your time.
Thanks.
Welcome.
All right, yeah, here it is. Let's open this in the old MS Paint. Where did I put it? There it is. Let's save that. I don't even like it. There. Is that visible enough? It is not.
Oh.
So I'm not going to get into all of the nonsense that this is because neurobio was hard enough when I took it, but yeah, down here, this is the choroid with, oh wait, no, it's not highlighting the right area. This is the choroid. That is not where my cursor is in my view. Sorry. In my brain, this is part of the choroid. This is actually the part that is or is not reflective. The pigment epithelium. My bad, everyone. My bad. I'm not going to edit that out. I can be wrong on YouTube. It's fine. Lots of people are.
So the best thing about science. I mean, not being wrong, but, you know, admitting it. Never fight your data, kids.
Yeah, because then pandemics happen. Anyway, so this is the light coming in from this direction. Nope, did it again. Why is paint was supposed to be easy? So that's your light. These little yellow arrows. That's our light, and it's coming in hot. But it's got to pass through our nerve fibers, which, in fairness, cells are kind of like clear to begin with, which is why we have to like do stains and stuff if we're doing microbio. So by and large, it just passes through mostly unhindered, and it comes down and hits these bad boys. Because our pigment layer is dark, it does not come bouncing back up. It just comes through and stays through. Otherwise, it would have two chances to hit the receptor cells, which is good for seeing at all, but not great for seeing well. Again, the lens flare problem. Although not exactly, that's a different phenomena. I don't remember what it is. Anyway, so this is traveling up. This is the thing I mentioned before, the horizontal cells. Oh, a cone for red was acted to, so all the cones for, I think, blue are suppressed for a while. Because get out of here, blue. And that's how we end up like seeing little dark gray slots in a white intersection between black boxes. That's a cool thing. I'll be doing that next time, some optical illusions.
Oh yeah, for sure. I hate those things.
Let me just close this down for now. But yeah, so that is the basic structure of the eye there. What we really care about for the moment is the lens, the iris, and I guess kind of the retina. That's fine. We can deal. So how do we use this light in a way that helps us? Well, this is everybody get your crafts ready. I'm gonna give you a second because here we go. I'm gonna start doing some craft time while I set up my desk. So everybody get your paper and your scissors and your tape and your aluminum foil and a needle. Because here we go.
I haven't done this yet, so teach me.
I did it twice. Just to be certain that I wouldn't F it up on camera, and if I did, I had something to fall back on. Okay. Here we are. I'm gonna flip that so that you guys can see it as I see it.
God, where did I put my pen? Oh, there it is. Okay.
Actually forget how to flip that. I have to do it through Discord. That's not worth my time. You guys can deal. So, you can use scissors. I'm actually going to use an X-Acto knife because these scissors are garbage. X-Acto knife is probably garbage too. But take your paper, or if you're fancy, a piece of cardboard. You need to cut out roughly a square or a circle or whatever, something big enough to like work with as an opening. And that's it, you're done. That was the whole experiment. Kidding.
Amazing. Can I bend the paper to do this because I don't have a fucking X-Acto knife on me?
Yeah. That's what I was gonna do that, but it's these scissors want to like rip instead of cut. Speaking of ripping, once you've got your hole cut, you want to take some aluminum foil, and I can actually use the scissors for this because brute force works. Way too much aluminum foil. You want it to cover, like, don't fold it in half or anything. You want it to like cover the hole with a little extra so that you can tape it. You did it! Doesn't need to be perfectly smooth, but like as long as it's not super crinkled, that'll help us a bit.
But this is fine.
I'm using way too much tape because this is America and I will... Oh no, I effed it up. Okay, there we go.
We're just covering the hole, yes?
Yeah. And then we're taping it down. And actually this is turning out better than the one I did before the stream, which is surprising. Nope, no it's not. Now it's bubbled up. That's fine. You want to make sure that it's taped down pretty good because you don't want like light to seep through on the edges. Then you got all that taken care of. I'll wait. I know that I'm a little fast.
Goodness.
So you can see less of the mask on my desk than I thought you were. Great. Prep the next visual while we do.
I did it. It looks retarded.
No, I mean, like, same though. It looks almost the same. So now this is the most important part. Take your pin or your needle, you poke right in the middle. If it's not exactly in the middle, then you're fine. It doesn't really matter.
Don't stress me out like this.
You can't really.
Where the fuck did I put my pen? Let's use this. It's probably fine. This square sucked.
Yeah, you can see the pinhole. Speaking of pinhole, that's what this is. This is a pinhole camera. It's not really a full-on camera. It's just the pinhole part.
Take from the other side too, see what happens.
Yeah, I guess that makes sense. Okay, got that visual loaded up. Or in a moment.
Please continue.
Now that we have this, we are basically going to be doing a demonstration of what the F it does. This is what I was doing earlier. Should actually, you can kind of see it with my fingers too, where there's the little light ring. Doesn't take much, but the hole be too small this time, or it might be because this is red and the camera is not down
This
here.
sucks. It's broken.
What do you mean?
Not doing shit.
Okay, I will admit it takes some finagling, whatever.
Okay.
Try to use black and see if that helps. Does take a bit of like trying to figure out where the hell the hole is. I think my hole might be too small. Let's fix that first.
Mine is a big hole. Oh, there we go. Looks retarded. What am I doing? What am I supposed to be doing here?
I mean, taking excuse me. You take the thing and you point it at like ideally a well-lit object while you're in a dark space, but for me I'm pointing it at a light source. Okay, I see the focal point. It's just not showing up. There it is. Okay, I shouldn't have used any color at all. So, yeah.
Okay, so a brightly lit object. I'm doing what now?
How do I work a camera? See that? Oops. See that?
Oh, yeah.
So you can find a focal point, which is going to be based on the size of your hole, which is going to give you the clearest resolution on that. For this one, because it's a fairly tiny hole, it's not very far, like it's this far away. Well, actually, you can kind of see it even from there. I am going to try one last time to show you what it is supposed to look like when you do this thing for like a solar eclipse, because that's actually how I got started on this project in the first place. Is, you know, there's a solar eclipse coming up pretty soon in 2024 and I wanted to do a thing about that. Okay, I don't know how well this is going to be visible because it wasn't visible before, but can you see? No, yeah, no, can't see it. Okay, well, there is right now in front of this camera, there is a very well lit ring that looks exactly like the light up there, but yeah, it's in a dark box. So yeah, this is a well and proper pinhole camera. I might make a better one because they're actually pretty fun. I'll post how to do it in on the Facebook page, and then I guess in the YouTube description. But more or less, it's that, except you use poster board to make a, what is that? 5 sides of a cube. On one side, you cut a hole and you do that. Only use something a little better than tinfoil. I mean, I guess you can use tinfoil if you want. It doesn't matter. And then on the top, oh, sorry, in the middle, you have a sort of diagonal thing of a mirror. And then on the top, you use frosted glass or wax paper or something that you can see light through. And so, let me show you a visual on this. Because that's what pulled it up in the first place. You... Ugh. Yeah, whatever. That's close enough. Oh, he's so sad. So this is what I've already talked about, right? Now, what we'll be covering next time is what if you do this 2 times? But for the advanced version of this pinhole camera, before we get into like some really cool stuff, we will be right. What was I saying? The really cool stuff that you can do instead of this is, as I was describing, do a horizontal or a diagonal mirror, and then it projects it kind of like this and then up onto a flat space, which you can see through like a projector screen, and that'll give you a pretty good representation of what you're looking at in focus. You don't really need to do this because there's no photo paper or anything involved. You're not actually using it as a camera, but essentially you're putting a picture in a box. And because you are using a mirror, it is reflecting it back, and you're seeing it from the other side, so it should appear in the correct orientation as the image is supposed to. So that's neat.
Great way to steal the soul of your crush.
Don't do that. And yeah, assuming everything goes well, next time Andrea will be special guest star here. We'll be pretty much assembling a camera, and then we're gonna touch on why that's awesome, because that's pretty fucking awesome.
Yeah.
Let's see. Did anyone have any questions before I like get into the wrapping up the stream thing? Because we're pretty much here at the 1 hour mark, so everything's going exactly according to plan.
Suspiciously so.
Right? Something's wrong. Yes, it's gonna be the twin TRL. TIL. It's a TRL. Twin reflex lens. I will post a link to one of those also in case you want to like have money and buy one so that you can assemble it along next time. But yeah. Okay. Andrea, do you want to like discuss real quick anything, or shall I just mosey us along to the next part of this? Where's my... Okay, yeah, I'll post the link then. Ending time. Here we go. Our shout outs. We have, let's see, 9, 4, 5, 6. We have six subscribers. That's awful, and I hate it. Why would you do this?
Why would you do this to me?
Anyway, shout outs to my subscribers for the patrons. We have a single junior scientist now, Chance Morgan. Congratulations, you're entered exactly one time into the raffle for this piece of cardboard today. We have 3 lab partners, which is 2 entries. That's Jane Jones, Andrea Marino, and Nicole Jakubiak. I don't actually know how to pronounce that, so we'll just say Nicole. We don't have any head researchers, nor do we have any big science. Oh, wait. Actually, no. We had some bitch called Rin Valternia was a Supreme Admiral of R&D, but now they've bumped themselves down to head researcher. So we have 1 head researcher with 3 entries into the raffle, and that's Rin Valternia. And then, get rid of the Supreme Admiral of R&D, the highest tier that we have.
Come on, let's keep it for at least another week.
Okay, fine. We've got our head researcher of Admiral R&D, is Rin Valternia, but at the highest tier, which is name your own title, we have the Empress of the Lab, Donna Carroll, who has 5 entries into the raffle. And now I'm going to do the raffle for this lovely piece of cardboard. Let's see who we got.
That's it. John's going down.
Alright, let me just do the thing. And it looks like today's lucky patron is Chance Morgan! You've won a box of cardboard. Congratulations. It's actually a lot cooler in person. I'm sure that they'll love it. Stay tuned next time for more nonsense. I don't think there's anything else. There's gonna be like a video chat hangout session after this if anyone wants to join, but this is it for the stream. I'll see you next week, and I'll post this on YouTube. Bye everyone, thanks!